Okay, so okay, awesome. Okay, so just use this keyboard to advance my. I will retain the mouse in case there's anybody in. But you will have access to my keyboard, allowing you to advance. You're very welcome. Disinformation.
Having similarity. That's the main. Yeah, so I gather, and I'm all in favor of these reservations.
Okay, 60. I was looking at. Oh, yeah, like a lot of people. You know, the finance.
Like to meet you.
No, it's yeah. It's very dark.
In your well-being.
That was part of it. Part of it, right. Yeah, I'm your chair. Yeah, good to know. Very good. Yeah. The part of stuff. I wrote this on volume recently, just working.
So how are your boys at LSC? Hey, Craig. Oh, Craig. Oh, thank you.
I did, yeah.
My fellow prime as well.
Oh, really?
Okay. Yeah, I'll be around. So how long should I let you be planning?
Oh, wow.
Quantum mechanics. I don't think I've seen these. I actually wanted to see you in Pittsburgh.
Welcome back. We are more than halfway to Barry's half retirement. So we have Isaac Wilhelm will be chairing the next session, but there will be, after the session, there'll be a little bit of a lunch break. You're on your own for lunch, but there will be some snacks and coffee awaiting you upon your return.
All right, so we're fortunate to have Jenann Ismael from Johns Hopkins University talking to us about a participatory universe in the realist mode. So let's welcome our speaker.
This is like a different talk than I gave the title for, and I just completely fished out on the other one. I worked on it, Barry, and I just couldn't. So I'm sorry that this is kind of a different talk. Just say something about Barry. So first, Barry, I'm gonna get emotional. So, Jenann, could you speak up a little bit? Yeah, okay. So, Barry, there's no one like you. I don't know. I don't know why I'm getting emotional.
Oh, man, there's no one like you.
That's not making it better.
So, I don't know anyone that sort of gives and receives love as readily as you, and God, this is so weird. So I don't know if you recognize like the sort of extraordinariness of the affection that people have for you. Because of course it's like the world that you live in, but I think, people smile when they hear you. And so God, this is so weird. So in our house, this is literally true. We never say your name without saying, we love Barry. Like this is God's honest truth. I'll be like talking to Brian. And I'll say, so Barry has this new paper, and we'll both stop and say, we love Barry. Honestly, I think in philosophy, I'm gonna echo something that Mike said, that there's just something about you that's so welcoming that you gather people around you. And it's like you sort of open the door and welcome people in, and they just want to kind of sit by you, like a cat sitting. Like a cat sort of sitting in a warm patch of sun. And then behind you, there's this sort of, behind that, there's this, behind that lovable exterior, there's this sort of ferocious philosophical mind that's kind of hungry and curious and absolutely tireless. So it's like a joy to talk philosophy with you, but you like tire me out. Like, learn to be grateful for the stories just because they give you a breather to kind of gather yourself for the next round. So when I was sitting, I was trying to think of how to characterize the sort of community of philosophy that I think of as your community. And I was having trouble doing that just because it's not really just philosophy of physics, and it's not really metaphysics, it's partly philosophy of mind. But I was sort of thinking, looking at the room today, it's like really, it's us, like it's the people in this room. I just wanted to say, Barry, you're sort of the heart and soul in so many ways. So you're not allowed to step back, like even a little bit, because you're sort of not as good without you as we are. Okay, so now it's for something completely different. So if you've been around philosophy of quantum mechanics for even a little while, everybody here knows that there's all of this discussion of the observer in quantum mechanics. So there's an intense focus on these interactions between the human being, the physical system, and uncertainty about how to treat the observer as just a part of physics. So you might wonder, like, why in quantum mechanics does the observer still suddenly become really important? The observer was always there in physics because physics is about the world, and observers, of course, are just part of the world. But I think in classical mechanics, we developed ways of dealing with that worked really well for a really long time. So when we're dealing with open subsystems of the universe, or particles, gases, complex systems, we keep ourselves out of the system that we're studying. So we treat ourselves as exogenous and our interactions with the system as interventions. So we're never sort of part of the explicit subject matter. When we're dealing with the universe as a whole, of course, we're implicitly included in the subject matter, in what we're talking about, but we kind of usually imaginatively take ourselves out of the system, out of the universe, picturing it as though it was an object that we're looking at from the outside. And all of this is a kind of convenient and mostly harmless fiction in classical settings, but it pushes out of view a phenomenon that I'm going to call interference. So that's not to be confused with this kind of interference. I'm sorry for the ambiguity, but you see why I use this term. So this is this kind of interference, the one that we usually associate with quantum mechanics, is something quite specific, and I'm going to use the notion in a much more general way. I mean something like the everyday notion of interference, a kind of interference that I'm interested in is present in both classical and quantum mechanics. But I'm going to suggest that seeing how it plays out in these two different settings gives us a new way of understanding the difference between these two theories. So what I'm going to do is I'm going to introduce interference with some examples and then distinguish it from what I'm going to call disturbance and ignorance. And the suggestion is going to be that interference is unavoidable in any setting in which a system is representing the domain in which it is situated. And it makes it impossible to stabilize certain features of the world as objects of knowledge. How interference propagates depends on the way in which the domain is connected. And what I'm going to say is in classical settings, interference is channeled and focused into the future. And in quantum mechanics, it's endemic. So that's going to be what I'm going to suggest. I'm going to argue that this is one clear way of understanding the sense in which the universe is participatory. And I'm going to explore ways of understanding that in a realist way. So most day-to-day physics, one is modeling, as I said, other systems or pendula gases, and we maintain this sort of provisional separation of subject and object, or investigator and system being investigated. Ultimately, though, again, we're part of the universe, so we act in the domain that we're representing. And this can create problems that make it impossible, as I said, this phrase is important, to stabilize certain features of the world as objects of knowledge. So this is something that people have unavoidably encountered when they're trying to make, for example, an artificial general intelligence. So the idea is that they want to program a system with a bunch of general knowledge about the world and the ability to model the world. And they're coming up against the fact that some of what happens, some of what the system is modeling, is stuff that they themselves do. So they're kind of thinking of an an artificial general intelligence embodied in a robot that has the ability to interact with the environment that it's modeling. So let me give you just a simple example. Suppose you want to program a computer to serve as a grand overarching database of physical facts about the universe, so just a repository of information about everything. So we bring in programming it with as much factual knowledge as we have. We program it with the laws of physics and the facts of history, what we know about monkeys of Costa Rica and everything, that every particular physical fact that we have knowledge of. And the goal is to be able to put any question of physical fact to it in some specified format, and it'll be able to answer correctly, yes or no, to any question of physical fact. But it's not hard to find a question that it can't answer truthfully. Just ask it, is the question that's is the answer to the question that's about to be displayed in the output channel no? So if you think this through, you'll see that any answer that it gives is going to be false. Mundane question of physical fact, what's going to appear in the output channel. But it can't answer truthfully. If it answers yes, clearly it's wrong. If it answers no, it's wrong as well. Either way, it's going to misdescribe what it actually wrote. So this might seem like an anomaly. These kinds of problems are, of course, familiar to philosophers and certainly to computer scientists. The problem is that what the computer does in giving the answer conflicts with what it says by rendering it false. So the first reaction to this is to try to suppress it or keep these kinds of questions from arising. So this turns out to be more subtle to accomplish than you think, because there's nothing wrong with the question being asked. It's a perfectly mundane question of physical fact. Any other computer could answer it truthfully. This computer could answer it truthfully at any other time. Another reaction is to try to recognize the difficulty and then try to quarantine. So again, in a realistic situation, this is more difficult than you think to accomplish. It's any proposition or any statement of physical fact is a node in a highly connected network, and there's no general way of isolating it from it's going to appear and sort of connect to other propositions. So for example, if the word node appearing on my screen at some time t is going to affect sort of electrical signals in the air, other computers looking at, or other screens pointed at my screen. Maybe the computer has a database and it records it in the database. And all of those sentences, all of those facts are going to be affected by the word no appearing on my screen in a second. Maybe someone will walk in the room and see it, someone will take a picture, and so on. So the effects are going to ripple throughout the network of truths. From the point of view of knowledge, you might think one wants to get as close to minimizing any disturbances that the computer's own activity has on the truth values of sentences in the field that it's representing. The reason that the problem arises, again, is because by saying things, the computer is doing things. And that creates a kind of interference between what it says, the content of the representational act, and what it does in giving the answer and making the representation. Nothing mysterious here. What's happening is that the computer can't stabilize the fact that the answer is meant to describe the word that appears on the screen, independently of giving the answer. And the thing is set up so that no matter which answer it gives, what it says conflicts with what it does. So they interfere with one another negatively. So negative interference, this notion, can arise in less direct ways. So, for example, boy tries to guess his Christmas present. So every day from June to December, he approaches his mother with a new guess, and she's promised, you get one question a day, and I promise that I'll answer two. Unbeknownst to him, though, his mother's waiting until Christmas Eve to make the purchase, and she's sort of determined to surprise him. So again, negative interference between what he asks and the answer to the question. Poll predictions that prompt responses that counter the predicted events, another example of negative interference. Predictions of Republican victory prompt Democratic turnout. Predictions prompt people to change their votes to make strategic choices, given where other votes are falling, that reconfigure the field. Again, interference. The predictions feeding into the domain and affecting what happens in a way that interferes negatively with what was predicted. Interference, in this sense, is different from what we think of as ignorance and disturbance. So in the case of ignorance, there is a fact that's well defined independently of what you say or predict about it. We simply don't know what the fact. In the case of disturbance, there is some fact to be known, but your attempt to ascertain the fact changes it so that what you see after your attempt to ascertain it misrepresents what was there before. That is, you change the thing that you're trying to look at in the course of representing, trying to ascertain. So in the case of interference, what I'm calling interference, the fact to be known is connected to our knowledge of it or our representation of it in a way that makes it impossible to stabilize independent. In that sense, I'm going to say there isn't a fact there to be known. There isn't a fact that is to say there anyways, or there already. So you understand what was going on with the boy and the Christmas present. The fact to be known in that case is connected to his questioning in a way that makes it impossible to stabilize independent. In this kind of situation, where the fact being represented is connected to the representation, where they can't be detached, I think what I want to say is the epistemic attitude doesn't work. The logic of knowledge sort of presupposes that the object of knowledge is there to be known, or there already, or there anyways. It presupposes that is to say non-interference. As long as one's activity is connected in the domain that one is representing, some of what one encounters will in fact be the ripples produced by one's own activity. And one can't, I want to suggest, treat those features of the landscape as potential objects of knowledge. So keep in mind here the example of the boy in the Christmas present. So it wasn't hard to find examples of interference in a classical setting. So I gave you a couple of examples. And I think it's genuinely problematic in some situations. So the boy and his Christmas present, that was artificially arranged, but stock predictions and election polls, in any case where predictions become public and affect the course of events being predicted, you really can't stabilize what you're representing independently of the act of representing. Knowledge is possible, I want to say, in the classical setting, because interference of this kind is controlled and it's disciplined. So everyday perceptual interactions, for example, are unaffected. These exchanges, that is an observer looking at an environment, have the logic of measurement. I interact with an object, my state after the interaction is correlated with the state of the object before the interaction. This allows us, this fact allows us to stabilize the spatial environment as an object of knowledge. That will, in its turn, allow us to stabilize the past, since the spatial environment contains systems whose present state contain information about the past, so fossils, footprints, written chronicles. You can think of these, in fact, as measurements of the past. The states of these objects is correlated with the states of objects or events in the past, So the external environment and the past are, from our perspective, there to be known. They're anyways, they're independent. So things are different in a classical setting when we think about the future. Philosophers, of course, tend to picture knowledge as a kind of relationship between a transcendent subject and eternal truths. That's not what it is. Knowledge is embodied and it's efficacious. Its whole point from an evolutionary perspective is to guide action. Present knowledge guides action, making it impossible, I want to suggest, to stabilize the future as an object of knowledge. Because why? Because anything that you predict, you can act to forestall, to avoid, to deter, to counteract. This is just the kind of internal version of pollsters and the election outcome. That is, predictions are feeding back into the domain and affecting what happens. So I want to say, in this sense, agency is the enemy of knowledge. We saw above that when we were talking about the computer, which would be the sort of grand depository of all truth, from the point of view of knowledge, we wanted to minimize the disturbances that the computer's own activity had on the domain that it was representing. From the point of view of agency, however, we want to use knowledge to guide action, making knowledge as active and as efficacious as possible. So again, present knowledge guides behavior, acting on its own predictions, and making it impossible in that sense to stabilize the future, at least the future that depends immediately on my representations of it. The ones that depend on my own voluntary behavior as something that's there to be known. Trying to stabilize the future as an object of knowledge is sort of like chasing your own shadow, or like a child trying to guess his Christmas present. In that way, and for that reason, I want to suggest that we shouldn't, as agents, treat the future as something that's there to be known. There anyways, there already. So the kind of instability that I'm talking about isn't mysterious. It doesn't threaten objectivity or realism. It doesn't even have to do with truth. The objective facts, I'm assuming, are the objective facts. What's true is what is true. It's just that our own knowledge and knowledge gathering activity is connected in the world. So present knowledge interferes with future fact and makes it impossible again to treat the future as something that's there to be known. They're independently of how we represent it. They're anyways, and they're already. But this isn't a feature. I'm sorry, this is a feature, not a bug. It's what makes agency possible. That's what agency is. It's using present knowledge to guide action to affect future fact. The agent anticipating the effects of her actions and using her knowledge to avoid, forestall, and counteract things she doesn't want, and to promote and encourage ones that she does, is effectively exploiting interference effects of her own knowledge. This isn't simply an epistemic fact. Our world is constituted in part by knowing agents acting in ways that depend on their knowledge. That means that it is not as a whole, that is, the world is not as a whole there to be known independently of our actions, simply because it includes us and it includes our actions. What we can and cannot stabilize as potential objects of knowledge depends on the way our own knowledge and our own actions are connected in the world. So in a classical world, I want to say we can take an epistemic attitude to the spatial environment and the past for the reasons I said, because those don't depend on our present representations. But in any attempt to stabilize our own immediate futures as an object of knowledge, will encounter interference. What I want to say is, in a quantum world, interference is endemic. The theory itself tells us that quantum measurements, that is, those attempts to find things out about the quantum world, those intensively analyzed interactions that bridge the effectively classical world of observers and quantum systems, don't have the logic of measurement in the specific sense that we can't stabilize the properties of quantum systems independently of our attempt to ascertain them. So for example, of course, in the famous double slit experiment, whether we see wave-like or particle-like behavior depends on whether we place particle detectors at the slits to observe position. Any interaction between a situated agent and a quantum system that we might use to try to get information about the system. So any of those much studied interactions that we call measurements of quantum mechanics, the statistics of which are predicted by the Born rule, I want to say interfere in the sense that I've been talking with the systems being represented. The difficulty has always been trying to understand what things could be like in a quantum world in a way that explains the empirical predictions of quantum mechanics. And the logic that we bring to our attempts to understand the empirical empirical predictions are the ones that are appropriate if there is no interference. So for example, we assume that the unmeasured quantities have values. We assume that if we perform a measurement and obtain a result reveals what was there before or there anyway. We assume that if we can predict with certainty that the result of a measurement would be X, we could infer that the quantity has a value X independently of the measurement. We assume, that is to say, that the properties that we observe are the ones that are there already or there. And then we find, of course, that the logic of quantum mechanics doesn't support these inferences, doesn't allow us to treat the results of quantum measurements as revealing something that was there already or there anyway in exactly this sense. The lesson of the last century of research in quantum foundations, so the history of no-go results from Gleason to Cochin-Specker to PBR and so on, established that Schrödinger evolution doesn't allow us to reproduce Born statistics if we hang on to the idea that these interactions are revealing antecedently existing categorical properties of measured systems. So there's a history of increasingly careful analysis to try to locate the source of the problem. There's a history of interpretation that either modify the dynamics or relax aspects of the there already or there anyway-ness to accommodate them. So much so familiar to most of you here. But this isn't an entirely alien phenomenon. Again, we cannot stabilize the properties of quantum systems as object of knowledge in the same way and for the same reason that the child can't stabilize the Christmas present as an object of knowledge. There's simply not something that's there to be known for us, independently of what we might try to find out about it, independently of the questions that we put to nature in the form of measurement interaction. Quantum mechanics, I want to say, reveals that the stability of the world is only apparent, that the structures that are needed to stabilize the world are something that is there to be known. Indeed, the structures that are needed to stabilize ourselves as knowers, the structures that are needed to stabilize a conception of ourselves as I's or subjects and the world as an it, are present only in an effective and emergent way. That doesn't mean that there's no world, only that the microscopic world isn't there to be known for us in a manner analogous to the way in which the future isn't there to be known for us in a classical. So in many ways, I think what I said is just something that we already know. So why is putting it this way helpful? I think it gives us a way of seeing the difference between classical and quantum mechanics that demystifies some of the weirdness of quantum mechanics. The phenomenon of interference is incontestable, even in a classical world. Any system that acts in the domain that it's representing is going to encounter this sort of interference. It arises in a classical setting as well, as a quantum one, and it's easy to understand with the sort of mundane examples like the void and his Christmas present. The difference between the quantum and classical worlds in this sense, or I'm suggesting, is not that there is interference in one and not in the other, but in how pervasive it is. And it also focuses, I think the focus on interference helps to foreground the fact that the conditions that allow knowledge in the traditional sense, so the stabilization of features of the world as potential objects of knowledge, the separation of subject, that is knower, and world as object of knowledge. Those conditions are contingent and they're special, they're not generic. So I call the talk a participatory universe in the realist mode, because I see what I'm saying as aligned with Wheeler's idea of observer participancy. So Wheeler introduced this idea of observer participancy to describe what he called elementary quantum phenomena. And his basic insight was that observer participancy, which he hyphenated as a single word, is the basic phenomenon. It's the general case, the ability to separate object from participation, or sorry, observation from participation. That is to stabilize the world as something that can be seen and known, and with it observers in the sense of emergent structures that interact with the environment in ways that obey the logic of observation or the logic of measurement. That, I want to say, is the special. It's not the general. So we see this kind of diagram everywhere. The one on the left, where we sort of model the agent. So we separate the agent from the environment, and we see it as kind of coupled to the environment by two channels, perception and action. But of course, the situation, the actual situation, demands that we put the agent in the world. The agent is acting in the environment that it's representing, and some of what it sees are, again, the shadows or the ripples caused by its own movements. The environment that it is representing will unavoidably create interference, and that will constrain what the agent can stabilize as an object of knowledge. Again, because its own knowledge guides how it acts, what the agent can stabilize as an object of knowledge and take a purely epistemic attitude towards will depend on how its own actions, including in particular the voluntary actions that are guided by its predictions, how those are connected in the world. So the difference between the quantum and classical world, again, is not that one is participatory and the other is not. It's that in the classical world, interference caused by one's own actions is focused and channeled into the future. The spatial environment in the past are unaffected by interference. In the quantum world, it's pervasive. So what should one's attitude be in cases where interference is present? I want to suggest that of the participant, not of the observer. We know both attitudes, attitude of the participant and attitude of the observer, because we live in the position of the participant in our daily lives. So the logic of these interactions, that is measurement interactions, quantum mechanics, is not the logic of measurement, but the logic of choice. Think about what a choice is. So a choice produces an action that interferes with what actually happens. I make my choices strategically exploiting interference. So for example, if I want to crop in the fall, I plant seeds in the spring. If I want protection when rain comes, I fix my roof. The mistake that the boy makes, the boy with the Christmas present, in his questioning of his mother, is that he treats that as a game of knowledge. That is, he thinks that there's an object there anyways, an object that's there already, and he's trying to guess what it is. And in that capacity, because of the negative interference, his failure is guaranteed. If he treats it as a game of strategy, he can use his questioning to get what he wants. He can exploit the interference. So our attitude towards the quantum world, I want to suggest, has to be something like our attitude towards the future in classical setting. Quantum measurements should be reconceived as a result of quantum choices. So if you think about the logic of measurement, measurements are characterized by the absence of interference. There's that suite of counterfactuals that are supposed to capture the idea that the results of measurement interactions reveal facts or properties that are there anyways, or there already. We assume that the values of observed obtain even if no measurement is performed. And even if a different measurement is performed, we assume that unmeasured quantities have values. And that if we could measure A and we could measure B, then the values we get for A and B are compatible and so on. The logic of choice, in that case, we don't expect any of these things. That is, we don't expect any of the things that are connected to our choices to be there already or there anyways. We expect what happens to be tied to what we choose, so that it doesn't happen whether or not we make the choice. We don't expect the results of our choices to be compatible with those the results of possible choices to be compatible with one another. None of that problematic suite of counterfactuals holds in the cases of choice. Ordinarily, we would understand all of this in causal terms, of course, and against the background of a certain conception of time. So we imagine that we live in a universe that's unfolding in time, causal relations run from past to future, and that's why we regard the past as fixed and the future as open. And why we take an epistemic attitude towards the past, and in our daily lives, a strategic attitude towards the future. And then we bring those ideas about time and causation into a quantum setting, and it doesn't work. We don't know how to impose those ideas on the phenomena that we're seeing in quantum mechanics. But what I want to say is keep those ideas, those kind of ideas about time and causation, out of here. Our everyday, out of the interpretation of quantum mechanics, our everyday ideas about causation and time grew up in a classical setting, where they are natural as expressions of facts about how interference propagates in a classical world. So if we look at the physics itself, the facts about how interference propagates are explained by deeper physics that makes no mention of causation and rejects that sort of everyday understanding of time. So the explanatory direction goes from facts about the way interference propagates in a classical setting to those ideas about time and causation that build those into a kind of metaphysical picture that frames our everyday ways of thinking. The actual metaphysics of classical physics, since Einstein, doesn't support that picture on the usual understanding. A relativistic universe is a four-dimensional manifold of events with no global conception of time. The reason that interference propagates asymmetrically into the future, and following here David and Barry, has to do with thermodynamics. So suspend your everyday kind of ideas of time and causation and try to understand things simply in terms of how interference propagates in these two settings. So think of it this way. It's sort of convenient to get yourself into this way of thinking by imagining sort of virtual worlds where you get to set the rules and then say how things are connected to one another. And you get to intervene in that domain by just activating nodes in the network. How the activation propagates around the network is determined by how the network is connected. And that will in its turn determine what the agent can treat in a situation like that. Oh, shoot. Okay, I'm gonna hurry up. As an object of knowledge. So Wheeler was someone that also made the suggestion that quantum measurements should be reconceived as quantum choices, and he emphasized the participatory character of our interactions with the quantum world. So recall Wheeler's analogy of game of 20 questions, which he used to illustrate the difference between classical and quantum world. So in the ordinary version, one person, the contestant, is left outside of a room while others agree on an object. Contestant is allowed back in and puts questions to players that they have to answer truthfully. So the contestant wins if he guesses the object that they have in mind in 20 questions. In Wheeler's version of the game, the players, unbeknownst to the contestant, don't agree on an object in advance. Whoever is asked a question by the contestant gets, so long as his answer is compatible with all of those before, to choose whatever answer he wants to give. Last player gets to decide whether the game is won or lost. The difference between the two games is that in the first game, the questions have an epistemic character. The answers that one gets reflect some antecedently agreed object, something that's there already or there anyways. In the second, the object is being sort of sculpted jointly in real time by the questioner and the responses of the players. So here's what Wheeler says: the world we once believed exists out there independently of anyone's observations, as his eye entering thought the room contained a definite word. In actual, this was a trick apparently. In actuality, the word was developed step by step through the questions raised as the information about the electron being by the experiment that the experimenter chooses to make. That is, had I asked different questions or the same questions in different order, I would have ended up with a different word, as the experimenter would have ended up with a different story for doing the electrons. Okay, so it is of course really hard to figure out what Wheeler actually thinks. From the perspective of quantum foundations, I think most of the people that have followed him have gone in the direction of cubism. So they've seen what their view as a radical departure from classical conception of physics. Their view is defined by opposition to realist views that treat the quantum state as an object, as describing an objective world. So according to them, the wave function quantum state is a user's manual for an agent, a tool that can be used to guide expectations and so on. So that's certainly one direction that one can go, but I don't think the features of the quantum mechanics that I've been pointing to need to push in that direction. I don't think this is about realism. It's about knowledge. It tells us the quantum world isn't there already or there anyways for embedded observers, not because there's no world or no objective world, but because there's no observation in the classical sense. The things that we're calling measurements don't have the logic that supports an epistemic attitude. Every interaction is participatory. Even in a classical world, we are participants, and we can treat the world as a whole as we can't treat the world as a whole as there already or there anyway, simply because it includes us in the most basic sense. In that most basic sense, some of what happens doesn't happen unless we do it. The basic sort of self-referential kind of interference affects other parts of the landscape as well, but because of the way that interference is channeled in a classical world, there are large parts of the world that we can stabilize independently of our own activity and treat as objects of knowledge. So again, perceptual interactions, inferences in the past. And what I want to say is that quantum mechanics tells us that our world, insofar as it is quantum, is more pervasively participatory than we thought. Tells us that our interactions with the quantum world have something like the character of the boy's attempt to guess his Christmas present. Tells us that we should approach our interactions with the quantum world in the way the boy, if he understood what was going on, should approach guessing about his Christmas present, in the way that a savvy player in Wheeler's version of 20 questions should approach his play, that is strategically, not with a purely epistemic attitude. Okay, I'm gonna skip a bunch. What I wanted to talk about, and I'm happy to answer questions about it, was I wanted to suggest that this can be accommodated in a completely objective ontology. And in fact, if you look at the way that measurements are treated in any of the, except for bone, but like in any of the kind of objective ontologies, Everettianism, relational quantum mechanics, the ones that don't modify the dynamics, you can see that the measurement interactions have something like logic of choice. Okay, so say one little bit more. So there's this discussion in the sort of Evans-Strawson Kant tradition in analytic philosophy that comes from the sort of its roots in Kant that talks about how the mind stabilizes a conception of self and world out of the flux of experience. So that account is a conceptual one. It talks about constancies in experience and talks about how the self becomes stabilized as a subject or knower at the same time that the world becomes stabilized as an object. Experience in this account is conceived as a relation between a subject and an object, and interpreted as a view of the world from the perspective of a body moving through it. So simple illustration in something like Mars' simple theory of perception is sometimes used as a template, where the idea is that you start out with visual experience, and the mind factorizes changes in experience into changes on the one hand in the world and changes in one's position in it. So the computation is one that minimizes change along both dimensions, imposing an order on what would otherwise be just a kind of blooming, buzzing computer changing patterns of light and color. The raw material for that story, though, is experience, and the world gets discerned in experience. And in the context of any physical theory, that story, the epistemic story, has to be paired with an ontological one that starts with whatever the theory treats as basic and shows how subjects arise and experience gets recovered in a world of the kind that it describes. I think am I pretty close? And then we go.
Officially, yes, but we can do a couple more minutes.
Okay, so I'll just very quickly talk about how to tell a story like this in sort of Everettian quantum mechanics, very schematically, and only because it illustrates in some way how a perfectly objective ontology would do something like this. So in Everettian quantum mechanics, the wave function is the basic object. Decoherence provides a physical mechanism for suppression of interference that tells us how a branching structure of internally classical looking worlds arises. In the context of these classical worlds, so the histories that form the branching structure, observers arise, and the world, it is in the context of those sort of classical looking worlds that observers as structures arise, and the world becomes stabilized as a potential object of knowledge, that is, as something that's there to be known, independently attempts to know it. So the account of how the classical world emerges from the quantum one in this kind of ontology is effectively an account of how the space is opened up for information gathering agents that accumulate knowledge and use it to guide behavior. And what Everettian quantum mechanics tells us is how those conditions arise by telling us how the classical regime, and hence the site of knowers and an objective world, is stabilized out of quantum. It also tells us why attempts by classically situated knowers to stabilize quantum systems as objects of knowledge generically fail. They fail because quantum measurements are not measurements in the sense that they don't have the logic of purely epistemic interaction. Because they don't have that their alreadiness or their anywayness. So I want to suggest in this kind of a picture, these two pieces fit together nicely. You get an understanding of how a conception of self and world is stabilized out of the flux of experience, and an understanding of how a classical world that supports the emergence of information consuming systems arises from a fundamental ontology. I'm going to skip it. Almost there. Okay, so if you look at quantum mechanics through these lenses, what I've said makes us aware that the conditions that need to be in place for articulation of subject and object, or the stabilization of the world as a potential object there to be known, are not generic and are satisfied only in an effective and emergent way. You see that the dissolution of those structures at the deeper levels. Quantum mechanics, one way of thinking of this is that quantum mechanics reveals a substructure to everyday reality that kind of belies the impression of stability, the illusion of separateness from the world. There's that kind of breakdown of the structures of subject and object, or self and I, or self as knower and world as thing to be known. I think Wheeler had that part right. All of the structure that supports those distinctions disappears at the fundamental level if you look at it through these lenses, and emerges with decoherence. So I'm going to stop at the edge of that cliff, because this is what I think the edge that quantum mechanics occupies. You go one way and you end up with this sort of cubism. You go the other way and you end up with the solid grounded interpretations that try to sort of erase superpositions and suppress interference. But I think that edge both separates and connects the two sides. I had a quick recap, but I'll stop.
Okay, questions? Barry, kick us off, and then I'll point to you.
Oh, thank you, Jim. Always such a provocative, interesting. Look, I knew some of what you were saying, but I want to see some things. So I would say, if I understand what's going on, I think the heart of quantum mechanics that gives rise to this is entanglement. That's the thing that does it. So somehow you didn't emphasize that, really, though, was there.
Yeah.
I began thinking as you were talking that still this is compatible with there being a God's eye view of the world. we just don't have it. Gods. Okay.
Yeah.
We're in the world. And when we interact with parts of the world, we get entangled with parts of the
Yeah.
world. So I'm wondering now about the past, what we think of as the past. It's the past part, and maybe you said this, but I know, you know, it's a lot went on. I'm sure you
Yeah.
said it. So it's the counterfactual structure of the world that distinguishes the past from the future. The things we do now, you know, the things in the past don't really counterfactually depend on now in any way that's really important. But the things in the future, I think that's the way I think about it. It says that's just on the mechanical structure of the world, not the quantum mechanical structure of the world. The quantum mechanics doesn't really agree with that, I think. So the past is still there, stabilized for us to find out about.
So, a couple of things. So first, I wouldn't say counterfactuals just because I think I would want the counterfactuals to come out of interference, but generically, the way that I would go is you get from the quantum world to the classical one, and then you get that basic perceptual interactions, have the logic of you get to infer from, you know, a basic perceptual interaction. You know, what was there or there anyways or there already, and then that grounds inferences to the past because that's a kind of accumulated records of the past. So that whole story goes exactly the way that you tell it. The only thing that's changed is that when you ask, and that all comes out of kind of the emergence of the effectively classical realm out of the quantum. The only thing that changes here is that when you try to impose that logic on measurements, that is interacting specifically between sort of, you know, classical observer and to get information about the quantum realm, then you lose the structure of measure. I mean, you lose the logic of measure. So that's the only thing that changes. Everything else goes through exactly as. But again, this is, I mean, what I should have said was, I mean, it sounded like I was making a bunch of pronouncements. This is just an attempt to try to make a sense of a way of thinking of this as very different. And that's a realist way of trying to make sense of what Wheeler was said. So you take quantum mechanics at face value, you introduce this notion of interference, and you get a nice and interesting way of making sense of the difference between classical and quantum mechanics that I think is ontologically unmysterious, but really foregrounds this idea that actually we're talking about knowledge and talking about the ability of treating the world as an object of knowledge is a kind of contingent thing that even in a classical sense depends on the absence of interference. And that very simple notion of interference is something that you'll see endemically in quantum mechanics. So it's just sort of foregrounding the way in which all of our sort of, you know, presumptions that we impose on quantum, on what we're calling measurement interactions are, you know, inappropriate.
So my first question is a quick actual follow-up on that. You said that fantastic talk. It was great. I really enjoyed this topic and this presentation and this change. I think a lot of stuff is fantastic. You were saying that one reason to do this is to ask if there's some way to make better sense of what Wheeler was trying to say.
Right.
I guess my first question is, how necessary is this? So the no-go theorems that you mentioned certainly make it difficult or maybe untenable to imagine that all observables that we go out and measure were simply passively revealing pre-existing properties of some underlying variables. But of course, they don't say that there can't be any variables, right? And obviously, as you know, the hidden variables approaches of which Vogel mechanics is an example, posit that there are some variables that we are passively revealing, maybe not all of them, but some of them are. So I guess I just wanted to confirm, given this interaction,
absolutely,
we're not
yeah.
saying this is absolutely necessary.
Absolutely not. It's just a different way of thinking of it,
Good.
potentially illuminating.
But now my question, which is sort of different. I'm trying to distinguish this problem of interference as you've described it from another problem that's at least connected, and I'm trying to understand if they're the same or how they're connected. And that's the impossibility of any brain or computer with finite storage capacity to know its own internal state perfectly, right? You have this self-referential problem that if you have a finite storage capacity and you're storing your complete internal state, like you can't, there's no memory system that can know its own state, because where would it store it, right? So, but imagine that we have some kind of memory system, this is obviously totally hypothetical, with an infinite storage capacity, right? Characteristic feature of an infinite set is it can be put into a one-to-one correspondence to the proper subset. So imagine we have some hypothetical, we're forgetting the actual laws of physics, hypothetical memory system that has infinite storage capacity, and it can store its entire internal state, and maybe the state of the entire like neighboring universe as a proper subset of the storage capacity, so it doesn't run out of space. Then if we go back to like the example that you'd indicated of, you know, from the beginning, you go to this computer that knows everything and you ask it this impossible question, how does it answer? This computer would presumably know that you were going to ask this question. It would know its own internal, it would know what all the atoms are bouncing around and doing, and so it would know what would come out on the readout. Whatever, something would come out on the readout, it would know what would come out on the readout, even if what comes out the readout is something that doesn't exactly answer your question. So I'm trying to distinguish between, so it seems to be that in that situation that a memory system like that could in fact make a prediction, and that the problem is not participatory interference, but we're actually running into the problem that realistic systems can't possibly
No,
contain it.
so I don't think that's good.
Okay, good, so we
And
clarify
so
that.
I didn't say anything about memory systems.
Right.
The setup was this. Can there be, and I'm willing to sort of go completely general on this, that can there be any system in the world that can correct the answer every yes, no question back? And I gave you that perfectly general argument that the answer is no. And then the question is, why not? And the analysis was, because the system's in the world, I can always find, if I'm allowed both negation and yes, I can always find a way of creating negative interference. So what's going to happen with the system that suppose has, let's say it has a, I mean, I've talked with you a
We've
little
talked
bit
about
about,
this
yeah,
before,
so
Right.
so what you need to do is find out if you've got a physical theory that you, or some account of, you know, physically possible computer that you think entails that it ought to be able to correct the answer. I'm gonna look at your physical mechanism. There's got to be a way of showing what's going wrong there. I mean, I can tell you in every actual case, so for example, why doesn't classical mechanics tell you there could be a demon in the world that could answer, right? I can do that. But I think the argument is perfectly there.
I have a
And I
follow-up.
think the
I'll-
structure is very familiar. The structure is just the Gödel structure. I'm not relying on Gödel here, but the same structure. You can't have a system in the world that represents truthfully the totality that includes it. But the analysis that I gave was a purely mechanical one that explains why this happens, how this happens.
Yeah, and of course, as a Gödel, there's a self-referential
That's right.
component to this,
Yeah,
exactly.
yeah.
All right, I have some follow-ups, but I won't monopolize, I'll talk to you after.
Thank you, Jenann, for the great talk. And I was thinking more about the choice interpretation of measurement proposed in the talk. And I was wondering, this word measurement we have in quote,
Yeah.
single quote, and it's kind of really suggesting there is ambiguity here in quantum mechanics. How to understand the choice ambiguity. But thinking, I guess this applies primarily to the case of contextual experiment. The one, for example, you did the Alvarez book, the split of Stern-Gödel experiment, you are creating the values, you're not measuring pre-existing values. But what about genuine measurements of the quantum state of the system or the variable of the system? Quantum state, say for the universe or a whole large system, then those things come with their own limitation to knowledge. So we know for a while that we cannot measure this precisely. And also recently, Roger kind of proved that you cannot even measure this imprecisely to get any information about the state of the system with any reliability higher than a point, and that's called observation typicality. And then this suggests that it seems like there's no psychological implications of measuring, say, a quantum state in a single copy or a few shots. So I was wondering how to reconcile this limitation to knowledge fact with the pragmatic or practical implications of the choice interpretation of quantum mechanics.
I'm not sure I followed everything. I think so this is a very schematic thing that just says that you're gonna have to be careful when and how you apply the logic of measurement and that you can't do it generically. So then it's up to you where to say, okay, in these cases, under these interactions, I can stabilize the world, I can't stabilize the thing that I'm trying to predict or thing I'm trying to inquire about independently. But that's all, I mean, that's all a much more detailed story about what your ontology is going to be. I've just said generically you can't do it, and what is it that tells us you can't do it if you won't fix the Born rule and Schrodinger evolution and it's the no-go results. I tell you can't do it, but that leaves it open like a whole.
For the averaging picture, we focus the Born rule, average, and rotation, the Schrodinger evolution. The only thing that's the variable and fundamental stuff is a quantum state, and we can show that there is no measurement of quantum state. It belongs to high-dimensional space, which is probability secured by the class hypothesis. Then suggests that there's no measurement of this thing that can reveal almost anything. I mean, this is a pre-existing value. It's not in the case of spin creation or branch creation. It's like the thing that is objective and yet not be measured.
Yeah, I mean, I'm not disagreeing. You're agreeing with me as far as I can. Yeah, I don't see where you think this is disagreeing.
In the sense of choice interpretation, how it is revealing about choices, agent.
Oh, okay. So when I'm carrying out a measurement of a kind, when I'm choosing whether to measure this or that, I can't think of that as having the logic of measurement, but I can think of it as having the logic of choice in the sense that the sorts of inferences that are licensed by the model are ones that don't support the counterfactuals that usually go with measurement. So you can't assume, measurements of incompatible observables, have a value independently and so on. So it's exactly that suite of counterfactuals that is being suspended in the case of choice. That's all I meant by logic. And I said choice because I mean it's a logic we're familiar with everything.
Thanks. So I just wanted to check a bit more about how to unpack, the metaphor of being there already. And I won't go through all the options, but just sort of two that I thought about that I'm not happy with. So you might think something is not there already if it's in some sense under my control. So something really. And that seems fine, but it just sort of makes it all trivial. We know that things are not there already just in virtue of having any control and stuff.
Yes. Yeah.
So not
exactly.
Well, are you happy to say it's just a trivial result? I didn't have to think about any of these interference effects. I just had to note that.
That's what interference is.
So I maybe just asked about the second proposal, because I mean, sometimes you spoke in terms of knowledge, which suggested it wasn't just analytic that being under control meant it was something not there already. But things that were not there already were things that I couldn't know. We talked about the logic of measurement and observation and knowledge. So I was thinking you had a sort of more epistemic thing in mind there. Then I got worried about that one too, because I think I know I'm going to be alive by this evening, but I know that's to some extent under my control. It has all the features of potential interference, but it's just potential. I know that it's under my control. I'm not going to make those kind of choices. I think that's I know. So it sounds like you're going to say, are you going to keep both the knowledge claim and the trivial claim?
So I think so again, I did a lot in a very short time. So I'll set the very basic distinction is between features of the world to which you can take a purely epistemic attitude, and those to which you can't. And the distinction between them is supposed to be that I can take a purely epistemic attitude, and I'm going to use your language only when I have no control.
So does purely epistemic mean just by definition, no aspect of control? Because, okay.
Pretty much, yeah. So again, I mean it to be really mundane. I would say, look, we're totally familiar with this distinction. Totally familiar with it. Analyze it in terms of interference, where that was just my notion that, attempts to represent or that the features that you're representing can't be entirely detached from your representation. Understand that probabilistic. And that's all that's going on.
I have more questions too, but
Yeah,
really, but thanks.
So I thought there's a kind of more mundane kind of interference that might be that I thought before this talk was all that's going on in quantum mechanics. So I'm wondering whether you think there's more than that. So here's the mundane kind of interference. I'm wondering whether the light of my fridge is on right now. And then by the time I open, it went on. And so I can't tell, like it just, that's not a measurement of the thing I wasn't, but I might have thought naively that was a measurement and like infer back like, oh, it was on, look, I just saw it and probably stayed the same. Well, I went wrong because I assumed that by opening the fridge, it was gonna stay the same and I could infer back.
Yeah.
Now I'm thinking that's like mundane interference is not spooky interference because the fact of the fridge, the light being off, say, it was there already, it's not under my control, it was independent. So I'm thinking, is there a difference between classical and quantum physics with respect to mundane interference? Yes. Is there a difference with respect to spooky interference, which is the one where, like, you're just like making a prediction about whether you're going to answer this question in the positive or in the negative? That's a spooky kind of interference, where there really isn't, in fact, independent of the prediction. And I'm thinking, I'm not sure I would want to say that even in quantum physics, because if I ask, what's the quantum state right now? Yeah, I don't have a way to measure that and then kind of infer back, like in the light of the fridge. But I think it is there already.
Yeah.
And I'm thinking the past is there. I mean, people have considered the possibility that maybe not, that maybe some of my choices kind of ripple into the past, and that's kind of spooky backwards causation. But I take it. Well, is that the view that you like? Is that what you're proposing? That the past is depends in the spooky way.
Okay, so
more in because we already know it has to depend a little bit on us in classical physics because of determinism and the laws are under control. But like, is there more?
So much to say. Yeah. Okay. So 3 things. So I distinguished ignorance, disturbance, and interference, and I meant those to be 3 different things. First, before I even say about this, I'll say what they are and what you described. Well, so first I'm going to say the thing that I wouldn't call interference. That was the point of the kind of mundane examples, but I do want it to be distinguished from interference, from ignorance, and from disturbance. So here's ignorance. There's a fact there, I just don't know it. Disturbance was the kind of case that you described. So look at the logic of what's going on in the fridge case. There is a fact there, yes or no, independently of my checking whether the light is on. But when I check, I destroy, I mean, I can't carry it because I change, I can't carry out the inference that says what I observe after was what was there anyways or already. But there was a fact that was there anyways or already. In cases of interference, now think of that this is why I really like the self-referential account. Because that's not a case of disturbance. There is no fact there already or anyways. So that's the 3 things I wanted to distinguish. You're absolutely right that epistemically it's a delicate matter. Whether this particular interaction is a case of interference or disturbance. And certainly, I mean, people have heard of quantum mechanics by saying, oh, there's got to be disturbance in every one of these interactions. So I'm just suggesting an alternative.
So it's more like the backwards causation views.
I
mean, I know causation is a tricky
so
word,
absolutely.
more like that.
So in the longer version of the paper, if you said to me, part of what I say, I go through examples of, I say, look, if you look at the objective ontology groups that treat dynamics as just quantum, so not, and don't add anything else, relational quantum mechanics, Everettianism, or retrocausal interpretations. The retrocausal is actually the closest to this, at least in the form that Price does, because you're not thinking of sending signals or back in time. What you're doing is you're taking the formalism. You're asking if I intervene here, and where interventions are something like I carry out a measurement, where do I see probabilistic effects? The quantum formalism, how do you see probabilistic effects? So in that very sort of thin version of retrocausal, this is retrocausal. This is particularly explicitly why I want the causal notions to come, not put in at the ground, but to come out of seeing how interference propagates. So classical setting, interference always propagates in quantum setting.
Hi.
Oh, yeah, no, you, sorry, not you, Connie. Or does Connie get privileges? All right, yeah, go ahead, I'm sorry.
So it seems, my understanding is there's an argument that is based off, okay, 2 attitudes we could take. One is the logic of observation or measurement, and another is the logic of control or choice or something like that.
Interference.
Yeah,
I don't want it to bring too much of our everything.
and I was thinking that, so you're saying there are lots of cases where this logic, where we thought there was logic of measurement, where it turns out we need to think about it in terms of the logic of interference. And I was wondering, why couldn't we make sort of the reverse inference? So we could say there were lots of things where we thought there was the logic of choice, where it turns out there's actually the logic of observation. So like what I would say is like, if I have me, I'm a system, and then there's some particle that's part of this system, so the fusion of me and the particle. There's some fact I don't know about it, which is whether it has the disposition for when I raise my hand, the particle to go left, or when I raise my hand for the particle to go right. And I thought when I was raising my hand, I was making a choice where I had some sort of freedom in deciding whether to raise it or not to raise it. But really what I was doing was just observing the pre-existing fact that was entailed by the dispositions, that when I do this, the particle does that, or when I do this, the particle does that. But it's not really the logic of interference. It's more the logic of my choices were really just observations that helped me learn about past dispositions.
Super good question. So I think I'm very bad at thinking on my feet. My initial inclination is to say, actually, in paradigmatic cases of self-referential choices, so the distinction between those two things breaks down. But I need to think about this hard. But really good question. I think epistemically it's always no question, but I want to say, at least in the paradigmatic kind of the choices are kind of, self-representational acts. In those cases, the distinction breaks down, but I need to think about it. Thank you for letting me.
Okay, so by Barry's ruling.
Thank you. I'm very nervous to ask this question because I really don't know much about this, and I'm not even sure if you have not already answered this question, but it's a follow-up on his question. And my Jacob, yes. And my question is, your image of quantum mechanics standing on the precipice, you can go down in what you call cubism or not. And I wonder if it can avoid falling down, even that it looks like your view is that an objective description of the world is inconceivable that an objective description of the world could be implemented in any system whatsoever. So what's the conception of the objective world if it's inconceivable that there's a description?
Good, okay, so yeah, this is good that you
But to be
asked.
clear, my comment was that it's not necessary that.
Right.
There are interpretations of quantum mechanics in which at
That's
least
right.
some things
Yeah.
are really out there that we're observing.
Well, all the ones, there are things
Yes.
out there.
Well,
mean,
yeah,
it's
but what I
just-
mean is
yeah.
specifically the things we measure, in some cases, we
We're
are
there
revealing
already, or
pre-existing
there
properties,
anyway.
just not.
That's right,
Yeah.
yeah, that's right. But I think it is worth saying, wait, oh, I forgot what I was gonna say. Hang on one second.
It's great, sorry.
Yeah, I know, yeah, it's
I
weird.
think it's disturbance.
Yeah, that was exactly. Oh, right, where. I literally forgot.
No questions, why is it objective?
Oh, right, okay, yeah, the precipice. I absolutely do want to say that there is a world, and it's only a kind of delicate question to what extent. You can treat the world as a whole in its entirety as there already or there anyways. The only thing that is impossible is that at least you cannot answer and treat as there already or there anyways in the most basic sense. Every single yes, no question of fact, but that leaves as an empirical matter how much you can treat as there already or there anyway. And that I think is a matter of physics. So that's partly what I want to say, which you take your theory, you situate the agent, you look at how the agent's activity is connected in the world. And that will tell you what that agent can treat at a particular time as there already or there anyway. So that's the idea. classical physics, it was very, you could treat the past, you could treat spatial environment, the stuff that, falls under your voluntary control. Well, that you can't treat that, right? So it was very intuitive. It's exactly the same thing, just as in quantum mechanics, there's, when you get to quantum interactions, you have to be delicate about whether you treat them as their own. But everything else, once you get in the classical, looks as you expect. That's it.
Super awesome talk. So I wanted to get a little clearer on what it meant for in the classical case the future should not be there, be known already. Because I took it like the claim was the psychological one that I can't treat the future as if it was there, but it's something more metaphysical or something like that.
Yeah.
And so I'm, thinking of the David Lewis paper on time travel or the appointment in Samara's story, like a merchant in Baghdad and learns he's gonna die that night in such a way and does everything in his power to stop it, he flees to Samara and then dies in exactly that way. And it certainly seems like he knew this fact about the future. It certainly seemed like this is a metaphorically possible scenario. I find it very natural to say, well, the future was there, we know about him already, despite the fact that he could, well, like he can control such and such part of the future, but nothing that would falsify the fact he already did.
Sorry, so is this a time travel story?
Well, so this one isn't, but you can tell time travel.
Yeah, so time travel, though, I mean, it is a bit different because already doesn't have a well-defined in time travel. The notion of the future is also the notion of the past, and we use already the time. You see what I'm?
Oh, well,
But in
David
the
Lewis
definition,
has the whole like it's already by your personal time, but your personal time differs from the objective time.
so on the closed causal, if this is time travel in the sense of closed causal loop, then even your personal time already doesn't have a well-defined asymmetric. What's in my future is also in my past for every event on the closed causal loop. But that wasn't your main question anyways, you were asking about definition. And the question was, is it incoherent for me to treat features of my future as they already are there anyways?
The question is, in this non-time travel version, where
Yeah.
the merchant learns the way he's going to die that night, seems like perfectly coherent to say that in fact he knew in fact about the future.
Yes, yeah, I think that's right. And there are all kinds of features of the classical world that are like that, like, sort of what's anything that's not directly connected to my own action. So, large scale features of the universe, like all of that is not connected to my action in a way that's going to not let me treat it as there anyway or there already. So I think what happens in the, in our everyday notions of knowledge. Of past and future, those are projections of, from our the notion of instability here that I was applying to the future is one this kind of interference that propagates in the future direction really fades off very quickly. It's centered on the here now and your own body. By the time you're getting to large scale features of the world or anything that doesn't depend directly or indirectly on your own action. Is there anyway or there. So that asymmetry is really closely tied to interference and properly understood as a very local.
Yes.
Thank you. You seem to be suggesting that to sort of in some cases where in context where interference is endemic, you take a participant of an interference stance. But there are also some contexts in which it's okay to take an observer stance because the relevant stuff is possible and it will be stuff. So I'm wondering if you entailed or you have thoughts on what happens when there might be conflict with these. So if you have like if you think your epistemics could be evaluated globally, and suppose there's some composition P over here, which you can treat in an observer way, but it's connected up in an interference way where, well, if you become less accurate in this composition P, then other stuff will become less chancy to get more accurate in your global state with more
more accurate. So it seems like in a case like this, we have some interference, we have some stuff that seems to be non-interference. But we can't just say, well, am I an observer or a participant?
Right, no, yeah, and so I think that's the general case, in fact, I mean, both in a classical and quantum setting, it's some mix of those two. You know, and it's always a matter of assessing how much control you have on the future that you're trying to form beliefs about. It's also a matter of degrees, so I think of it in probabilistic terms, and I call it detachment. So, but it's what you think of as ordinary, you know, how much control or how much causal influence is my present action going to have on that future. So I think of those two as completely tied up with one another, and it's perfectly familiar in the classical setting that we're always making that difference. There's something that I guess what, you know, my voluntary activity might have a few, but for most, like, except in very low probability situations and depending on a lot of scaffolding, I might as well treat it as there already or there anyway. So that's.
Yeah, so I want to ask a question about your epistemic attitude versus the non-epistemic attitude. Like, if you go back to the child, okay. Now, if the world is deterministic, so we design a system that puts now on the table a certain object that contains the answer. For example, we have a piece of paper with the answers as to what the kid is going to be. That's going to be facing down. And of course, to make it coherent, I can't possibly burn out the paper because you can make it such that the paper burns down when someone touches it. That's not
Wait,
coherent.
say that last bit again?
You can make it such that the paper disappears or burns down when you touch it. Now that's coherent. And what attitude should I take now towards composition? Well, in a sense, the epistemically is right there, it's on the table. I could in some sense look down, just physically can't because of the laws of nature. But that's just like the original case, just like we added this piece of paper on the table. So what difference should it make to the attitude that metaphysically speaking, this composition has?
I'm not sure I understood the question.
Okay.
So you're imagining a case where it's like the child with the Christmas present, and there's a piece of paper with the name of the Christmas present.
Yeah, because say, the laws are deterministic, so you can derive. Yeah, so some Laplacian demon is outside the room is derived, and knows exactly what question the child is going to ask, knows exactly the way the mom is going to think about it, and wrote down the final gift on this piece of paper.
Good, okay, so this is what I want to say about that. I mean, this is a big interference arises only where sort of your action is directly attached to the thing that you're inquiring about. What happens in the case with you know, is like in a kind of ordinary deterministic case. If I can predict what you're going to do, but I keep, you know, my prediction secret, then there's no interference. But if I tell you my prediction and you use that to do the opposite, then there's interference. Does that help?
I'm just wondering, in the original case, there is interference. When the kid tells, there is interference in the original case. Right? When the kid
There
tells-
is interference in the case,
In the original case where the kid tries to guess the gift.
yes.
But now suppose we just add the answer on this piece of paper.
Oh, I see.
Then-
what
then
you're
I see, like, when I
saying.
look
So
at
there
the-
is some fact that screens off the
Yeah, but
child.
then why just adding this piece of paper to change the epistemic attitude they have?
Well, but they're two physically different cases. So in the case that you described, there is some fact, namely the writing on the paper that screens off the child's guesses from what actually happens. In the cases I set it up, the mother is actually letting her action be guided by what the child guesses. Those are two completely different situations, and your attitude should be different between them.
I guess like if I'm a deterministic, in a deterministic world, there's no relevant difference. If the paper exists, it's the same.
Yeah, so determinism is another thing to talk about, and I do have, I mean, but it not, you know, I have something to say about that.
Do you want to be added to the queue? Okay, so I was next. I was gonna ask you, so people are parts of the world on your view? So. So does your view then imply, and you say like, aspects of the world that are connected to our own actions can't be stabilized as objects of knowledge, so does that mean that I am myself the least knowable feature of the world insofar as my own actions. I am a quantum system. I could try to measure myself. You're a quantum system. I could try to measure you. I could sort of treat you as an object in this, that you can treat me as an object and I was just wondering, yeah, what does that mean for sort of measurement and causal influence when the sort of thing that we're doing an experiment on is a agent in the world who's capable of these kinds of
So let's talk about classical case. For a second. Okay. Ordinary everything. Does that make me, and in particular my representational activity, the least noble thing? Absolutely, because that's the most agential. That's exactly the. So I'm not sure why the quantification.
Oh, okay. So this is not gonna be an illustration of anything distinctively.
Yeah. So I was intrigued by your view because it connects actually to a view I have about so-called response-dependent concepts. Let's take a very simple example, being cool. Being cool, yes. So let's suppose to be cool is to regard oneself as cool. Okay. Now I ask, am I cool?
Right.
I face a choice.
Exactly. So
Okay.
that's positive interference.
Yes,
Yes.
okay. Now, being cool is, now that's a very, to me, a very intelligible case of the kind of thing you were talking about.
Yes.
And the reason I understand it is that we have a response-dependent concept, that it's part of what it is to be cool, to respond in a certain way to being cool. I'm wondering whether you have a similar view about physical magnitudes. Don't think of them as purely physical magnitudes out there in the world, so to speak, but as partly response dependent. Somehow they're entwined with our responses in the same way that being cool is. I don't know whether that is your view.
So it is, but the dependence there is a causal dependence. So the idea is that when you're carrying out a measurement, yes, absolutely, it's the thing that you're trying to find out about or forming a representation or forming a belief about. That is the product of an interaction with you. Has a response dependence, but it's not a constitutive response dependence in the quantum case. It's a causal, it's a physical.
Though it could in principle be conceptual, but maybe that's going much further than
That's going further, that's the,
Yes.
that's the cliff.
Yeah, I see.
All right, let's take a period.
That's really what it is. Thank you so much.
Over here instead of here, just tomorrow.